Hey guys, today we're going to be doing Unit 4, Lesson 4, Math Modeling Day 1. So this is part of our functions unit, and a lot of times real world problems often result in math models that involve functions. Okay. These functions need to be constructed or built based on the information given. When we build functions, we definitely have to translate the verbal descriptions to math. And this is something we're going to be doing a lot of in calculus. So, it totally makes sense to kind of work on it in this course. The basic steps to building a math model. Okay, if we need to, we're going to draw a picture. Sometimes the picture is given, sometimes you have to come up with it yourself. So that's just based on the problem. Then we're going to write our basic function. And that function is going to be, let's say we're doing the area of something. We're going to take like our 4th grade, function, what your teacher taught you. Area equals base times height or length times width. However you want to write it down. And then we find a way to relate our variables. This is a little tricky, and we're going to work through several different types of examples. And then the last step is we want to write it in terms of one variable. Okay. So that's pretty much it. Anytime you want to think of, what you have to do, you're going to kind of work through those steps in your head. In our first example, we're going to let p equal xy be a point on the graph of y equals x squared minus 1. And then we want to express the distance d from p to the origin as a function of x. Okay. I did not include a picture of this just because I wanted us to come up with one in case you're ever in the situation that you have to do this. X squared minus 1, again, we should know, is a parabola shifted down 1 unit. So it would take, and basically it doesn't have to be perfect. This is just a little sketch to help us. So there is our function, y equals x squared minus 1. And we're going to have some point p on that function. And that point p is an ordered pair xy. And we want to express the distance from point P to the origin, which is the point 0, 0. And we want to express that distance as a function of x. Okay, so when you see the word distance, that's going to help you pick your basic function that you want. Okay, distance is our key word. So we're going to start with the distance formula. This is one of the reasons why we went through some of the basic geometry we did in the beginning of the year. So hopefully you remember the distance formula is square root of x2 minus x1 squared plus y2 minus y1 squared. Now we're going to take and we're going to substitute anything we can from our picture, from our given, like from the information from the problem. So if I want the distance between that point and the origin, I want to find that distance. And again, it's going to represent the distance anywhere on the given curve. We're writing a function. So I'm going to just substitute what I was given. x2 minus x1. X minus 0 squared. y2 minus y1. Y minus 0 squared. And all I did was take what I could off the picture and put it into my formula. Now I'm going to just kind of smush it up a little bit, right? Because we don't need those zeros. If they were numbers, we would leave them. Okay, now here's the hard part. When I read through this formula, it's d equals x squared plus y squared, the square root of x squared plus y squared. I wanted to have all x's. That's our goal. We want to get all x's. So I have to think of a way, okay, or basically we should think of it this way. What equation relates x and y? Right? I need to figure out a way that I can substitute my y value for x's. And if I go back up to my initial equation I was given, doesn't y equal x squared minus 1? So what I could do now is I can take, and for this given, right, I'm going to replace y with x squared minus 1. And you're not really done here. I mean, technically you do have a function in terms of x, but in this class, we're going to work this out and we're going to write it nice. So we're going to square this guy, x to the 4th minus 2x squared plus 1. And if we can, we're going to combine any like terms that we can. X to the 4th minus x squared plus 1. Okay, so yeah, we are going to simplify this. We are going to basically, in non-math terms, we're going to clean it up. We're going to write it so it's a nice, neat package. And this is your answer. I could ask you questions. I could say, what's the distance when x is 2? What's the distance when x is 3? We could do that now that we have a function. I mean, in actuality, this really is distance as a function of x. All I need to do is plug in an x value and I can get the distance from any point. Okay. I'm not going to make you do that. All I want you doing right now is being able to come up with different functions. Let's try another type of example. A rectangle has one corner in quadrant 1 on the graph of y equals 25 minus x squared, another at the origin, a third on the positive y-axis, and the fourth on the positive x-axis. Express the area of the rectangle as a function of x. Okay. So we want to write an area of the rectangle, right? This is, I'm going to highlight it actually, if I can. We want to find a function that represents that area. And basically, when we want that function, if you think about it, if you move the point here, that area would be that. If we move the point here, the area will be that. So we're writing a function to find different areas. Okay. We start with area equals length times width. This is my parabola. This is my 25 minus x squared parabola. And there's my rectangle. So if I want to describe the area of this rectangle, I don't know the ordered pairs. I don't know the coordinates of the point, but I do know that from this to here is x units. So I could rewrite my formula with information from the problem. My length is x, and my width is the y value of the ordered pair. Now the last problem here, the last little problem is, remember, we want it in terms of x. So I want to get all x's. I need to replace that y with x. So I go back to my information and I look for something that relates, right, the x and the y value. So I know when I write this, I can replace y with 25 minus x squared. And once again, and this is going to be because when we use this later on in the year, we want to make sure we distribute. So this area as a function of x, right? The area of the rectangle as a function of x, that's the notation for it, is going to be, I'm going to put my negative x cubed plus 25x. I'm a little bit of a freak. I like to write it in standard form. I always like to have the highest power first and go down by powers. And again, this is only because it's going to help you in the future. Okay, so basically that's it. That's what this topic is. We're going to take a given situation. We're going to look to see what they're asking us to write the area for, and that's what we're going to be doing. In our last example today, a circle of radius r is inscribed in a square as shown below. Express the area of the square as a function of r. Go back however you want to write down that basic formula. Whenever I have anything that's a square or a rectangle, I go to length times width. I don't know why, I just do. You could use side squared, but that sometimes confuses me. So I usually resort to length times width. Okay. Now I want to figure out what this length of this square is in terms of the radius. And if we look as we wrap, as we take this radius, let's say I put it there, right? As I move it around the circle, I have r and I have r. So the length of this side of the square is 2r. And we notice that the same thing's going to happen for the width, right? From here to here is also 2r. And we work this math out. Now that I have all r's, my area as a function of r is 4r squared. So today it's just about coming up with the functions. We're not really doing anything with them yet. We're just coming up with functions. Express the perimeter of the square as a function of r. Now, whenever I'm dealing with perimeter, no joke, I think add up the sides, right? Isn't that what your teachers told you when you were learning perimeter? Way back when? I mean, we know it's going to be 2L plus 2R, right? We have length, width, width. So that's the, fancy formula, so to speak, but just think about it as adding up the sides. So 2 times L plus 2 times R. What an idiot. I'm sorry. 2W. That's why I just do add up the sides. So my perimeter as a function of R is 4R plus 4R, which is 8R. Okay. It would have been a lot easier, right? 2, 4, 6, 8. To just add up the sides in your head. But it's good to know how to set it up with the actual notation, because that can be helpful when your examples get a little more difficult. And that's pretty much all we have for your day, for today. So practice with your homework, and we'll be back tomorrow. Thank you.